Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS3301 Data Structures. The unit is Stacks and Queues. In this video, we are going to discuss about double-ended queue, that means Dequeue. The double-ended queue. Double-ended queue is also a queue data structure in which the insertion and deletion operations are performed at both ends, that means front and rear. That means we can insert at both front and rear position and can delete from both front and rear position. This is a representation of double queue. Here the front and rear points are marked. Then these insert and delete operations are performed at both positions, front position as well as the rear position. Then double-ended queue. The double-ended queue can be represented in two ways. These are follows. First one is a input restricted double-ended queue. Then second one is the output restricted double-ended queue. Input restricted double-ended queue. That means in input restricted double-ended queue, the insertion operation is performed at only one end and deletion operation is performed at both ends. This is the input restricted double-ended queue. This is the representation of input. Here the insertion and deletion are performed in the front, but the deletion is performed only in the insertion is only performed in the front end, but the deletion is performed in both front and rear position. This is the way of representing the input restricted double-ended queue. Then next one is the output restricted double-ended queue. That means the deletion operation is performed at only one and the insertion operation is performed both ends. Both are opposite to each other. That means here the insert operation is both end and deletion is performed in only rear end. But in the input restricted double-ended queue, the insertion is one end. That means in the front end only. The rear is performed on both ends. This is the difference between the input restricted double-ended queue and output restricted double-ended queue. The application of queues. Some of the common applications of queue data structure are task scheduling. That means the queues can be used to schedule tasks based on the priority or any order in which they are received. The next one is the resource allocation. That means the queues can be used to manage and allocate resources such as printers or CPU processing time. Then next one is the batch processing. The queues can be used to handle batch processing jobs such as data analysis or image rendering. Then next application is message buffering. Queues can be mainly used for buffer messages in communication systems such as message queues in messaging system or buffers in computer networks. Then event handling. Queues can be used to handle events in event-driven systems such as GUI applications or simulation systems. The next one is the traffic management. Queues can be used to manage traffic flow in transportation systems such as airport control system or road networks. Then these are the another some of the applications. In the operating systems, often use queries to manage processes and resources. For example, a process scheduler might use a queue to manage the order in which the processes are executed. Then next, in the network protocols like TCP, UDP use queues to manage the packets that are transmitted over the network. The queues help to ensure that the packets are delivered in the correct order and at the appropriate ratio. The next one is the printer queue. In the printing system, Queues are used to manage the order in which print jobs are processed. Jobs are added to the queue as they are submitted, and the printer processes them in the order they were received. The next one is the web servers. Web servers use queues to manage incoming requests from clients. Requests are added to the queue as they are received, and they are processed by the server in the order they were received. Then final one of the application is breadth first search algorithm. In the data structure, the breadth first search algorithm uses a queue to explore nodes in the graph level by level. The algorithm starts as an given node and adds its neighbors to the queue and then processes each neighbor in turn. These are the some of the applications use the queue. Thank you.